The next topic is the risk and risk premium. Before we see more detail about the risk and risk premium, first of all, we will learn how to compute the expected return and the standard deviation, because the expected return, the average return will represent the return for the portfolio, and the standard deviation is the proxy of the volatility, which is the proxy of the risk. So let's look at the scenario analysis first. Scenario analysis show some possible economic scenarios, like the good economy, bad economy, normal economy, and find the probability, likelihood, and find the HPR, holding period returns. So if you have these probability distributions and the HPR, holding period returns, for each economic possibility, then we can compute the expected return, which is the mean value of the distribution of the HPR. Mean value is the average. And then variance, which is the expected value of the square deviation from the mean. And then standard deviation is the square root of the variance, which is the same unit as expected return. So let's look at the scenario here. So we have four possible scenarios: severe recession, mild recession, normal growth, and boom economy. 5% severe recession, mild 25%, normal 40%, and boom economy 30%. And this is the HPR. Negative 37%, negative 11%, first two scenario, 14% and 30%, next two scenario. So let's look at Excel spreadsheet to show how to get the answers. So the first of all, we have to take, so the formula is, in fact, the expected return will be sum of, so you have n cases, then probability times holding period return for each case. Okay. So first of all, let's find the probability times, so probability times holding period returns. Probability times holding period returns. And just copy, right? And that's the, and sum of these four will be expected return, which is 10%. So 10% is the expected return. Okay, 10%. Now, let's find the deviation from the mean return. So this is the mean return, so average. If this distance is far, then you're more volatile, right? So this is the deviation when severe recession, negative 37% minus now expected return, right? Same way, mild recession minus expected return, normal expected return, and boom, HPR expected return. So let's just fix it, D8, and then copy everything. Then that's the deviation. Now this deviation actually has maybe negative or positive. So to mitigate this effect, we just square this deviation, which makes all positive number. So first of all, square of this, and then times the probability. Okay, and copy everything. And sum of these four again is variance. The variance, if variance is high, then you have higher possibility to have your return is far from the means, which may be may represent high volatility. But this is squared number, right? So this unit is not same as the return. This is not 3%. So let's make this same unit, just take the square root of the variance. Then we have, in fact, 18.63% standard deviation. So that's the volatility. If the standard deviation is lower than this one, then you're less risky. If the standard deviation is higher than this one, it's actually riskier than this scenario. So you can use this similar spreadsheet to get the expected return and the standard deviation of the scenario analysis. And for exam, I will provide this template for the solution to solve these type of problems. So again, the expected return is sum of this one, and the variance will be actually sum of, again, probability times now HPL, each HPL I minus expected return on I, right? N squared. And the standard deviation, usually just sigma, will be the square root of the variance. Okay. That's how to find the expected return and the standard deviation for in scenario analysis. Now, why these two numbers are so important? Because there's one typical distribution, probability distribution, called the normal distribution. So normal distribution is the distribution that actually see symmetric distribution, and this is the average. And then it's exactly same as the 50% whole and 50% here. And exact same shape. And this is the mean. So if the distribution is normal, first of all, the center of the distribution should be the expected return. This case, the expected return is 10%. Okay. Now, one more thing. Now this is the standard deviation. Okay. So if the standard deviation is 20% with 10% expected returns, then let's go to the one standard deviation. So this is R minus 1 times standard deviation. This is R plus 1 standard deviation to make the negative 10% to 30%. And if the distribution is normal, this area will be about 68% the possibility. More accurately, 68.26%. So it means that we have, so if you pick any year, so first of all, this average means if you pick any year, the highest frequency, highest possibility, the best guess for the return of that year will be the 10% expected return. Now, you pick random year again, and you have 68% possibility that your return lie between negative 10% and 30%. That's what it means. So we can actually describe the distribution by mean and standard deviation, expected return and standard deviation, if the distribution is normal. In many cases, return distribution is normal actually. Now let's take another standard deviation. So this way, this is all plus 2 times standard deviation, all minus 2 times standard deviation. And this area will be now 95%. So again, the range is now, if you pick a random year again, you have 95% possibility that your return lie between negative 30% and the 50%. That's what it means. Let's go another standard deviation. And this will be all minus 3 times standard deviation, and this is all plus 3 times standard deviation. And these areas now have almost everything, 99.7%, more than 99%. So it means that if you pick random year again, you have 99, actually more than 99% possibility that your return lie between negative 50% and 70%. So if the distribution is normal, we have this type of work that we can actually can have. Now, there's concept called the value at risk, VAR. The value at risk is, now people usually concern the worst case, right? Worst possible case. So let's find worst 5% possible case. So like about 5%, maybe about here, I think, yeah, right? Worst, if this area is like 5%, this point is probably the worst one that we can have. This point called the value at risk. So how to find the value at risk? Now you can find the value at risk using the standard deviation score. So the standard deviation score can be calculated by this one, and actually for a normal distribution you can actually find the 5% standard deviation score in Excel. So let's go to Excel again. In fact, let's go to this, yeah, and you can find it actually by having norm S, I, and V, and say 5%. Then you have negative 1.64485. This is the actually standard deviation score of this one. So in fact, value at risk equals to your expected return on I minus 4485 times standard deviation. You can also directly calculate using now norm IMV. Now first one is the possibility, so 5% means is now 10% and standard deviation 20%, right? And 22.9% will be the worst possibility, like a 5% probability. So if you look at again the here, this will be, now if you have 10% and 20%, then about negative 22.9%. That's the kinds of the worst case you can expect. It's called the value at risk. So you can calculate the value at risk using the Excel formula, norm INV, and then this is probability, so it's 5%, and expected returns and standard deviation, and usually just 5%, right, for value at risk, and you can find it. Now, one issue is return distribution really normal? Well, sometimes it is normal, sometimes it's not actually. But especially shorter return usually more normally distributed, because first of all, continuously compounded rate, which is EAR of that, which is E expected return again APR minus 1, will be normally distributed. So this is go to actually normal distribution. Now annual return, however, is possibly not normal, but most monthly return is normal. In fact, the gap between the EAR and the APR for monthly rate is actually narrower, like the smaller than the annual one. So shorter time periods usually more normal. Usually monthly rate is pretty normal. So many cases we use monthly returns when we analyze the market. Now there are another measures, statistical measures to show the normality. One is kurtosis. Kurtosis is how fat the tail is. So like this type of distribution or this type of distribution. So if the kurtosis equal to 0, the closest to 0, that's normal. So feta tail, like if distribution is this way, so probably the riskier way, right? Then kurtosis is negative. In this case, kurtosis is positive. Now the another one is the skewness. Skewness is now how skewed it is, like this. So for normal, skewness equal to 0. For this case, skewness is positive. In this case, skewness is negative. So this also two different types of statistical measure may show the normality of the distribution. Now, you can also have just the historical data instead of the scenarios. If you have the historical data, this is how to find the expected return and the standard deviation. First of all, the return is simply just a simple average. Okay, so it's a sum of the all return minus divided by n. Now the variance will be, now you have expected return and you find the deviation again and take a square and sum of that, and instead of just having the the multiplier lie by the probability, you just divide by n minus 1. Okay, and note that this is n minus 1, not n. Standard deviation is the square root of the variance. Okay, now let's talk about risk premium. The risk premium is expected returns of any asset minus risk-free rate. And what risk-free rate means? Risk-free rate is the rate of return that can be earned with certainty, no risk. So usually just a T-bill rate, right? Treasury bill rate is the only risk-free rate in the world. Now, this risk-free rate is certain money, so it's actually just value of time. You delay your consumption, you save it, and you surely make this one. So this is not related to the amount of the risk. This is just time value. Now, this difference, the risk premium, expected return I minus risk-free rate, will be the additional compensation for taking risk. If this is high, then you take higher risk. This is low, you take lower risk, right? Excess return is now rate of return in excess of risk-free rate, which means that if you have return minus risk-free rate, that's the excess returns. Now, risk aversion is everybody has different tolerance about the risk. Some people just try to avoid the risk. They don't want to lose money. Some people aggressively investing in riskier assets to make higher returns because they can tolerate their loss more easily. So everybody has different risk and aversion. They call the reluctance to accept the risk. If you're more risk averse, then you don't like risk. Now the price of the risk is the ratio of the risk premium to variance, which means that now the risk premium, this one, divided by the variance of the return. This kinds of the 1 unit of variance, like the additional risk premium per 1 unit of the variance. That's the price of risk. Now there is another ratio to measure the risk the return per volatility, the risk, which is the Sharpe ratio. The Sharpe ratio is now usually using portfolio. So portfolio return minus risk-free rate, which is the risk premium of the portfolio, right? Divided by standard deviation. If Sharpe ratio is high, it means that you actually make more returns per 1 unit of the risk, which is good. So this is actually used to rank the portfolio performance. This is the historical Sharpe ratio. You can see the world market and US market, and based on this information, so you can just read it. And this is another like world portfolio returns, see the return variance and the volatilities, and see T-bill is pretty stable. This is the T-bill. This is T-bill. This is long-term bond, less volatile, and large stock is highest volatility, but it actually shows the, I believe, the highest higher return than long-term treasuries, right? Small stock more volatile, highest return. So risk return, they have trade-off. It's called the risk return trade-off. You take higher risk, you expect higher returns, because the market should give you the sufficient amount, like enough reward to take risk.